example of 3 point mass bodies which are placed on a straight line, and the distance between them is, between point mass body A and B it is 5 meter, between B and C that is 10 meter, and all of them they lie on a straight line. We are asked what is the force which is experienced by, let's say, the 5 kg point mass body. So let's see first the interaction between this and this. We know that is when we say F is equal to G m1 m2 upon r square, so this is always the force of attraction between the two masses m1 and m2 separated by distance r. Similarly over here, when we say this is 1 kg, this 5 kg and this 1 kg, so it means this, there is also going to be force of attraction. This will attract it this way and this will also attract it this way. Right now we are bothered, that is what is the force which is going to be experienced by this. So let's talk about this force only. We don't disturb any other body over here. So this F1, if you say, that is how this is going to attract this one. This F1 is going to G m1 m2, let's take this as m1 m2 upon the distance between the two, that is 5 square. So this is one force. We also see that there is a 2 kg point mass body also. So this will also attract it this way. It is not that this 1 kg body is kind of obstructing its path or influence. No, it is not. We cannot have gravity screens. We cannot have something which can obstruct this force of attraction between the two masses. Whatsoever you do, there is going to be force of attraction between any two particles, any two bodies in this universe. This force may be large, force may be very small, but there is always going to exist the force of attraction between any two particles in the universe. So over here, 2 kg body, this 5 kg body. So once again, this 2 kg body is going to attract it this way. So this is going to attract it this way. We say that is this F2. So it is going to G m1 m2, that is m1 we have taken this 2 upon, now the distance between the two is 10 plus 5, 15 square. Both the forces F1 and F2, they are in the same direction. So net force on A is going to be F1 plus F2 in this direction. So now let's consider what are the forces which is experienced by the body B. There is 5 kg point mass body over here and there is 2 kg point mass body over here. This 5 kg will attract it this way, 2 kg will attract this way. Both the forces they will in opposite direction, and over there we can find the net force eventually. So this we call, let's say, force F1 is going to be G m1 m2 upon r square. This is, now we are bothered about the B body only. M1 m2 we take it as 5 upon r square, this is 5 square, and F2 is, let's say, in this direction onto this is going to attract it this way. So this is going to be, F2 is going to be G m1 m2, that is 1 into 2, you take 2 into 1 or 1 into 2, that is one and the same thing, upon r square. Now this is 10 square. So one force is this way, the other force is this way. Over here, if we compare the two, we see that is numerator of this is greater than numerator of this, and denominator of this is smaller as compared to this. So obviously the net force is going to be in this direction. Algebraically you can subtract F1 minus F2 and you can find the net force on the point mass body B. If we talk about what is the force which is experienced by the point mass C, then certainly onto C there is one force. This is B. Let's call it the F1. Also obviously this F1, we are not bothered about whether they are same or not. We are just for this, onto this there are two forces. One is we are calling F1 and the other is we are calling F2. F1 is, let's say, between this and this. So F1 is going to be G m1 m2, the two masses, this and this, 1 into 2 upon the distance between the two, that is 10 square. So this is one force. The other force onto this in this direction, F2, is because there is a mass, other mass also over there. This one and this is second. Now we are understanding what is the interaction between this, that is what is the force of attraction by this onto this. So it is going to be obviously in this direction the force of attraction. There is always force of attraction obviously. So it is going to be G m1 m2. Now we are talking about this mass and this mass, 2 into 5 upon r square. What is r? The distance between the two masses. Now we are understanding the interaction between these two bodies. So even the distance also that will be considered between these two bodies. So it is 15 square. Both the forces in the same direction. So F net on C is going to be F1 plus F2, and that is going to be in this direction. So this way we can easily find what is the force on this. Now here all the point masses, they were in a straight line. What if they are not in straight line? If they are not in straight line, we know how to resolve the vectors. Then these forces, they cannot be added or subtracted algebraically. It was only that is over here all the 3 point masses, they were in a straight line. So the forces, they were aligned along a line. So it was easy. That is, we can simply add the two forces, or we can subtract it, and we can get the answer. If they are not aligned along a line, then certainly we may have to use, that is, how to resolve the vector, how to find the vector, and how to find a resultant of vector. Those concepts which we had done earlier in the Newton's laws of motion, they become very handy, very useful over here. Let's see. Let's say this is a square ABCD with each side, let's say A. So this is, each side is A, and on all the vertices we have a equal mass M over here. We are interested what is the net force which is experienced by any one of the masses. Let's take this mass. So over here we say, that is, its neighbors, there are three neighbors, that is, which can interact with this mass. One is this, second is this, third is this. This is going to attract it this way with the force F, and this F is going to be G M1 M2, that is interaction between these two masses, M1 M2, both of them they are M only, divided by A square. Similarly, this force also, if we say, that is G M1 M2 upon R square, the value is going to be same only, because the masses, they are same, the distance is also same. But if we talk about this, that this is going to attract it this way along this line, because these are central forces. When we say universal law of gravitation, or that is the force of gravitation between these two masses, that is central force. The force is going to be along the line joining the two, and it is always going to be attractive force. We are talking about this. So if this is A, so this is going to be A square plus A square. We have used the Pythagoras theorem, so it comes out to be root 2 into A. So when we talk about this force, this is, let's call it as F dash. So F dash is going to be G M1 M2 upon R square. What is the distance between the two? Is root 2A. Root 2A square. So now if we draw the force diagram of this point mass body B, we see that there are three forces which are acting on it. One force is acting this way, this is F. There is also a force acting this way, the same amount of force is acting this way at an angle of 90 degrees to this first force, but the magnitude is same. And over here we have the other force F dash. Obviously this angle is 45 degrees. We know their magnitudes. Now we can use the resolution of vectors, and we can easily find what is the value of the net force. And F net comes out to be Gm A square in brackets root 2 plus 1 by 2. This is a net force which is going to be experienced by any of the masses in such a configuration.